Hello and welcome. Today we are going to see about some properties of vector addition and scalar multiplication. So if you have three vectors named as u, v and w, and let's say alpha and beta be two real numbers, then so as you see here, v plus u plus v is the same as v plus u. So if you change the position of u and v under addition, so the result is the same. So we call this one is commutative property. Also, if you first add u and v and then add w, so which has the same result as adding v and w then adding u, so we call it, this one is associativity. So the third one is when you have a vector u and vector 0. So here a vector 0 means, for instance, if it is in Rn, so which is represented by 0 vector is represented by 0, 0, 0 n times. So these are n tuples. So adding 0 to any vector gives you the vector itself. So we call this property is existence of identity. And the fourth one is when you have a vector, so we call it u, and if you add another vector v, and if the result is 0, then we call this vector is an inverse, or we call it additive inverse, which is usually the same as this is equals to minus of u. So the fifth one, so if you have this alpha and beta, they are scalars, then multiplying u by beta, then multiply by alpha is the same as multiplying both of the numbers, the real numbers, and then multiply u. So this property we call it associativity of scalar multiplication. Then we have the sixth property, which is alpha plus beta, or we can distribute the vector multiplication here through this alpha and beta. So this is distributivity of scalar multiplication. And when you have alpha, and if you have two vectors, then you can add both of the vectors and multiply by alpha, or you can also multiply each vectors by alpha then add. So this is also we call it scalar multiplication of distributive property of a scalar multiplication. So this is all about today's video, and if you are looking for the proof of this theorem, check out the next video. Thank you for watching.